let us try to do the cascading of multiplexer. I just told you why we need the cascading. Suppose I have the stock of the less order multiplexers, and I want to make higher order multiplexers. In that case, what I can do? Okay, in that case, I need to cascade the multiplexer to get the higher order the multiplexers. Okay, so what are the procedure to make the higher order multiplexers? So yeah, the procedures are something like similar to the decoder. Okay, uh, but because in the decoder we have less input, more number of output, but here in the mux case we have more number of inputs and only one output. Okay, so at the end we need only one output, not the many outputs. Okay, so the opposite kind of concept will be utilized. Okay, so let us see how we can utilize that concept. So the first step is I am considering the number of input needed for the final circuit is m. Okay, and the number of inputs in the existing mux is n. So the number of mux in the stage 1 will be m divided by n. Yeah, this is all we have already done for the decoder. So the number of multiplexers required in the stage number 1 will be m divided by n. Now I need to check whether this n1 is greater than this n or not. If it is, like if n1 is greater than n, then we need some multiplexer in stage 2 as well. Okay, so the number of multiplexers in stage 2 will be n1 divided by n, and we will keep on repeating this stage until this condition is not satisfied. Okay, and if it is not satisfied, then I will use some logical gate to control all the inputs. Okay, so this is the procedure to cascade the multiplexers. Okay, so yeah, this is similar to the decoder one only. There is no difference between these things. So let us try to see, try to take some example and try to cascade it. Suppose I have to construct 4 raised to 1 line multiplexer with the help of 2 raised to 1 mux. Okay, so can anyone tell me how we can construct? What are the different logics that are needed? Okay, different mux that are needed. Okay, so let us try to see here. Okay, so if I am considering here, if you see m is equal to 4, n is equal to 2, so the n1 will be m divided by n, and that we are getting 2. So n1 we are getting 2. So 2 number of mux will be needed in the stage number 1. Now, because see here, n1 is greater than or is equal to n, this is true. So we need to go for the second one. So what I have to do? I have to find the n2, and n2 will be nothing but this will be the n1 divided by n, and this will come around 1, and then next condition will not be true. Okay, so total number of multiplexer required for this one will be 3. So let us try to see how we can connect those things. Suppose this is the first multiplexer having 2 inputs, I0 and I1, and one control signal, which is the S0. Okay, and I am considering the output of this multiplexer is O10. What is the meaning of this O10? I will tell you. Now we need one more multiplexer that should be connected at the input side, and let us consider the multiplexer inputs are I2 and I3. Okay, and the control signal is again S0. Okay, and here output is O11. Okay, now can anyone tell me how we can connect this to get the 4 inputs? So see here, we got the 4 inputs over here. Okay, now we have one more thing that can control the operation of this multiplexer, and that is this control signal. Okay, so if the control signal is, because see, I can see this control signal is nothing but this is the active high. Okay, so if it is active high, what does it means? This will be enabled if S0 is equal to 1. Okay, so if S0 is equal to 1, then this will be enabled, and vice versa. Okay, so this is the case. Now Let us try to check it out. Okay. So how it will work? What will be the connection? Can anyone tell me?
Sir, S0 is a control or enable?
Yeah. Yeah,
Sir,
sorry, control. Yeah, S0 is the control. Sorry, I told you enable, right? Yeah, by mistake I told you enable. This is the control one. Yeah, this is the control signal. Yeah. So S0 is equal to, yeah, I think I made one mistake here, right?
yes, sir.
I told you enable kind of thing. Oh, sorry. S0 is equal to 0. In that case, this I0 will be selected, and S0 is equal to 1, then I1 will be selected. Yeah, sorry. I'm absolutely sorry. I made a mistake. So here, S0 is the control signal that decide whether I have to pass I0 or I have to pass I1. Okay. So can anyone tell me how I can connect it? Okay. So see here, if I'm connecting these two inputs to the same signal, okay, then what will happen? And if I'm considering this one of the control signal, then what will happen? If this S0 is equal to 0, then this is also 0 and this becomes also 0. So I0 will be transferred to this O1 and I2 will be transferred to this one. Now, because out of these two things, I need to take only one. I need to consider only one output. So I need one more multiplexer that will be controlled with the help of these two inputs. Now, this S1 will decide whether I have to pass this O10 to the output or I have to pass O11 to this output. Okay, so let us try to see what are the different combinations here. Okay, so if S0, so here this is the first level, this is the level 1 where we need two multiplexers, and here we have a level 2 where we need one multiplexer. So total 3 multiplexer is needed. Now let us try to check how it is working. If you see here, if S0 is equal to 0, okay, if S0 is equal to 0, and if I'm considering the multiplexer number 1, so if S is equal to 0, in that case I0 will be transferred to the O1. So O10 is the output and I0 will be transferred. Okay, if S0 is equal to 1, then this I1 will be transferred to this O10. If I'm talking about the multiplexer 2, because multiplexer 1 and multiplexer 2 both are working simultaneously. Okay, so the I2 will be transferred to the O11 if S0 is equal to 0, and I3 will be transferred to the O11 if S0 is equal to 1. Okay, so this is all about the first stage. Now we got these two outputs, and these two output depends on either it will be I0 or I1, and this output can be I2 or I3, but at a time we need only one. Okay, so the next mux that will decide, that will become the input for the next one, and if S1 is equal to 0, this will be transferred, and if S1 is equal to 1, this will be transferred. Now let us try to see what are the possibilities. If S0 and S1 is equal to 0, 0, okay, if S1 and S0 is equal to 0, 0, in that case I0 is transferred, I2 is transferred here. But because S1 is equal to 0, in that case, only this O10 is transferred. So I will get this O1 transferred to this output. So O1 will be transferred, O0 will be transferred. If it is 1, in this, if it is 1, like 0 and 1, in that case, what will happen? This I1 will be transferred. Okay, I1 will be transferred means this I2 will be whatever the I1 over here, this is nothing but this is the I2 for the 2:1 multiplexer. So I will transfer this logic through this one. Similarly for other combinations. So for all the combinations, like if the combination is 0, 0, then I0 will be the output. If combination is 0, 1, then I1 will be the output. If 1, 0, then I2 will be the output, and 1, 1, I3 will be the output. Okay, so this is simply how we can decide and how many multiplexers are needed to make the higher order marks. Okay, and here S0 and S1 will combinedly act as a control signal for this multiplexer. So now we can see here total number of inputs are 4, 2 control signals are required here and one output is needed. So this is perfectly work as a 4:1 marks. Here is the homework. You have to construct 8:1 marks with the help of 2:1 marks. How can anyone tell me how many multiplexers are needed for this case? If I have to construct 8:1 marks with the help of 2:1 marks, how many? 3. How you are saying 3?
7.
Sir, sorry.
7.
7. Okay. Let us try to check. Okay. So the first step will be 8 divided by 2. That will give you the 4. Then you will get 4. Then 4 divided by 2. That will give you the 2. Then 2 here. 2 is again, it is equal to this one. Then I have to make 2 by 2. So that will give you 1. So total number of marks required will be 7. So 7 is the correct answer. So you required 7 number of gates. Okay. 7 number of marks. Is there any doubt on this? I think the point is clear. Now let us try to see here one tricky question. Suppose if I have to construct 8:1 marks, yeah, if you can go to the previous slide. Here the homework was like I have to construct 8:1 marks with the help of 2:1 marks. Okay, this is absolutely correct. This is fine. Okay, but if you see here in this problem, I have to construct 8:1 marks with the help of 4:1 marks and with some logic gates. Logic gates may also be added. Okay. So how to construct this one? How many marks are needed? Can anyone tell me?
2.
2. Okay. So is only 2 multiplexer is sufficient to design this one? Or you need some other things? Okay, so let me explain that circuit first. So initially, if you divide this one 8 divided by 4, that you will get 2. So in the first stage, you need 2 multiplexers. So here I have a 2 multiplexers. Okay, the inputs are from I0 to I7. Okay, now our objective is based on this input combination. Okay, so one very important thing. How many control signals are needed to construct the 8:1 multiplexer? How many control signals are needed?
Sir, 3.
3 control signals. Okay, but if you can see here in 4:1 multiplexer, we have only 2 control signals. Okay, so from where I will get the third control signal? Can anyone tell me from where I will?
We can use.
Yes, we can use.
We can use 2:1.
2:1 where?
Hello.
Yeah. Where you need to use 2:1? Yeah, your answer is absolutely correct. Okay, I will tell you
maybe
how.
after this output, because we are getting 2 outputs, so 0 and 1. Then after this, we can use 2:1 marks, and here we'll pass one control signal to.
Absolutely correct. Absolutely correct. Okay, but suppose if I do not have the stock of 2:1 marks, then how we can solve that? I have stock of logical gates. Okay, I have a stock of logic gates, but I do not have 2:1 marks. Yes, of course, whatever you just responded, this is absolutely correct, and this is one of the possible solutions to design this structure. Okay, but if I don't want to use 2:1 multiplexer, I have to use only 4:1 marks and the logic gates. Okay, so in that case, how it can be done? Can anyone
not gate use कर लेंगे.
One NOT gate can be used, and that can control the enable signal. Okay, and that may work as a control signal. Is it?
Yes.
Yes, sir.
Okay, then again we will get 2 outputs. How to control these 2 outputs? Because we need only 1 output, right? Yes, of course, you should absolutely correct. We have 8 inputs here.
We can use a gate which can give only 1 output.
Okay,
like
so
OR gate.
OR gate is required. Absolutely correct. Because see here, we have 8 inputs here. We have 2 control signals over here, and I can use this enable signal as a one of the control signal, okay, by using one inverter. And because we are getting 2 outputs and we want either of one output, so either of one means we need to use OR gate. So one OR gate will satisfy this condition. Our requirement will be like we can accommodate our requirement if we have one OR gate. So let us try to make it. So you have given the solution of this problem. So the first control signal will be S0, second control signal will be S1, and the third control signal will be one inverter that will be connected, both the enables will be controlled with the help of inverter, and that will act as a one of the control signal. Okay, so if S0 is equal to 0, then the first mux will be selected. This will not be selected. And if S2 is equal to 1, in that case, this will be selected and the first one will not be selected. So we can select any one of the mux based on the S2 status. Now, because we are getting 2 outputs, okay, I0 and I1, and we need only any one of these. Okay, so in that case, we can use one OR gate that can give you the output. So this is one of the possible solution. And before, you have already explained the alternative of, instead of this OR gate, you can use 2:1 multiplexer. Someone responded before. Okay, you can use one 2:1 multiplexer, and instead of enabling this thing with the help of control signal, we can directly enable them, and we can use one 2:1. So here I have a one circuit, one mux, second mux here, first control signal S0, second control signal S1, and we need what 2:1 mux, and that will act as a one of the control signal. So S0 and S1 will come from here, S2 will come from over here, and the enable signal, because this is the active low, so I need to connect all these to grounded. Okay, so this should be grounded. So this circuit will act as a 8:1 mux. Okay, so these both are the possible solution for that one. But might be in questions it may be asked like I have only 4:1 mux, not 2:1 mux, and the logical gates, then this will be the solution. Okay, but if it is not given, like you need only you need to use only 4:1 mux, in that case you can use both. The solutions are fine, both are good. Okay.
Sir, out of these two, which one is more beneficial in terms of time complexity?
The first one will be better, because if you can closely look into the multiplexer itself is made of the logical gates. Okay, there may be multiple, like if I want to make 2:1 multiplexer, there are multiple logical gates are involved in this one. Okay, so the gate or the delay penalty will be more as compared, delay and area will be more of this 2:1 as compared to the single OR gate. So the more optimized one is the first one instead of the second one.
So what is the interior diagram of multiplexer?
I have already told you before. Let me go back to that slide. Yeah, this one. This is the internal diagram. This is the 2:1 mux.
Thank you, sir.
So if you see here, we have 2 stages. One stage is this one stage is this one. So if I have a 2 stage, means 2 TD time delay will be required. And if you are using only OR gate, in that case only TD time delay will be there. So the first design will give you the optimum output, or the delay will be less in the first design. Okay, doubt is clear?
Yes, sir.
Okay, so this is all about the construction of 8:1 mux. Now here are some questions that you have to solve. Okay, construct a 16:1 mux using 4:1 multiplexer. Okay, so this is easily doable. One important thing that you have to remember, see here, here m is equal to 16, okay, and n is equal to 4 here. And if you see, this m is nothing but this is like, if I can do some square of this n, then I will get the m. Okay, but now if you can go back to the previous slide, in the previous slide, this m is 8 and n is 4, and there is no relation like n to the power n square. There is no relation like this. The relation is like 2n. So if this kind of relation is there, 2n kind of relation is there, in that case, the only this 4:1 mux or the lower order mux will not be sufficient to design. Let me repeat it again what I'm saying. Let me go back to the previous slide so that you will be able to understand. If you see this figure, in this figure, m is equal to 4 here, n is equal to 2 here. So m is nothing but this is n to the power 2. This is satisfying this condition. Okay, so if n is equal to 2 means m is equal to 4. If this condition is satisfied, then only multiplexer will be sufficient to solve the purpose, to design or to construct the higher order multiplexer. Okay, now let's go back to the next slide. In the next slide, what we studied here, this is not satisfying this condition. M is equal to n square is not satisfying. It required m is equal to 2n kind of relation we have. And if it is the relation like this, then only this mux will not be sufficient to design this 8:1 mux. You need some other kind of arrangement. And the other arrangement is like logical gate or other kind of multiplexers. So this is really very important point. Might be this kind of question may come in the gate exam. Okay, there is a possibility because this is very tricky kind of. So you should know how many gates are required. Or might be the question may be asked like, I have to construct 8:1 mux with the help of 4:1 mux. So will 4:1 mux will be sufficient to design this logic? So there could be yes, no, not possible, something like that. So you have to give like, no, you need some additional gates. Maybe the question may be what other gates are required other than the 4:1 mux to design 8:1 mux. Okay, the question may be, it may be given an AND gate, OR gate, XOR gate, something like that. Okay, so you have to pick this OR gate. So these kind of questions are possible here. Okay, might be you got a new things here. Fine. So this is all about 8:1 mux with the help of 4:1 mux. So you need to remember this relation. So let me write it somewhere so that will help you. Okay, so if m is equal to, yeah, I think I need to write in the instruction slide. So if m is equal to n square, then yeah, this kind of relation if we have, maybe multiple in the multiple order. So n1 nx, I'm talking about nx or something like that. So you can say, so if m is equal to n square, then only mux will be sufficient. If m is equal to 2n additional gates, additional empty gates required. Okay, so this is important thing that we should remember. Fine. So the second question is how many 2:1 mux and the number of stages are required to construct 30:1 mux. Okay, so you can check it out and you can solve it.